Sentinel-2 is a multispectral imaging mission delivering high-resolution imagery with a systematic global coverage at a temporal resolution of 5 days under cloud-free conditions. Part of the Copernicus program, the twin satellites of Sentinel-2 provide continuity of spot and Landsat image data and contribute to applications such as land management, agriculture and forestry, disaster control, humanitarian relief operations, risk mapping and security concerns. Sentinel Application Platform, SNAP, is an ESA community platform created to increase the exploitation of all Sentinel missions. On top of the basic functions, like opening a product, exploring its components or navigation tools, SNAP integrates dedicated toolboxes. To enrich the capabilities of Sentinel-2 Toolbox, the Research Center for Spatial Information within the University Politecnico of Bucharest developed DAS Tool, a processor for Sentinel-2 Level 2A product analysis that can be installed as a plugin in Snap. DAS Tool follows the content-based exploitation plan for end product generation and entails two main functionalities, each one including several dedicated algorithms. Exploratory visual analysis, a procedure aiming to highlight predominant data features for the scene content and enable advanced data visualization that will help the user to perceive certain aspects that are not always reflected in the visible part of the spectrum, supporting data understanding. Semantic annotation, a data content representation focusing on the identification of relevant scene characteristics and further grouping based on a specific criteria by means of classification methods. This step will result in a classification map emphasizing the existing categories of objects inside the scene. Following this video, a demonstration of how advanced visualization and semantic annotation in DAS Tool can be combined in order to assess the impact of forest fires in Australia in 2019. Due to large presence of smoke, an RGB visualization is not relevant. Factor analysis will enable visualization through dimensionality reduction. The analysis will be performed at patch level and requires human interaction. For semantic annotation, mean and dispersion will be the extracted feature and support vector machine the employed classifier. We start with data visualization and access the factor analysis function. It is available under the raster menu, the DAS Tool submenu, or by right button mouse click directly on the product. There is a dedicated graphical user interface containing a preview of the analyzed scene and one for the area of interest marked with a blue patch on top of the scene preview, control tools for the size and position of the patch, as well as a list of bands to be included in the processing. The patch depicting the area of interest can be also moved manually, by mouse click on the scene preview, or it can be automatically selected to match the area with the highest dispersion. Once all settings are in order, click OK to proceed with the computation and display the results. The factor analysis is a dimensionality reduction methods which analyzes the interrelation between the 13 spectral bands based on a set of unobserved latent variables. Redundant features will be removed, while the relevant information will prevail in a new 3 bands combination whose visualization uses a pseudo-color representation. Compared with the RGB data representation and natural colors, factor analysis is able to highlight the area covered by dense smoke. Side-by-side product visualization with synchronized navigation will help comparison. The demonstration continues with the supervised approach for the semantic annotation process. For this, the user must define a training set for the classifier before launching the DAS tool functionality. For each new class identified in the scene, access the new vector data container under the vector menu. Use the drawing tools to define regions on either of the 2 data visualizations, RGB or factor analysis. All vectors will be stored in separate layers for each semantic class and stored as a mask of the initial product. This images include the following semantic classes: forest, smoke, burned area, low density urban, high density urban, agriculture and water. The semantic annotation function is located under the raster menu, the DAS tool submenu. The graphical user interface contains 3 tabs representing the main steps of the workflow involved. First one refers to the selection of input and output data for the process. The image to be analyzed will stand as the source product. From the products already opened in Snap, select the same product it was used to define the training set. The target product represents the result to be obtained. Moving to the second tab, we enter the interface dedicated to parameter setting for feature extraction. This is a step to complete from the top to bottom. At first, the user must choose the approach for the type of analysis, which is patch or pixel-based. The list of available feature extraction algorithms below will update for each approach. For this use case, mean and dispersion is the algorithm selected, as part of the patch-based analysis. Specific parameters for each feature extraction algorithms are displayed in the bottom side of the window. Adjust accordingly after defining which bands to be considered for the computation. Finally, the last tab contains the list of features classification methods, updated according to the type of intended analysis. Each classifier comes with specific parameters that are displayed in the middle of the window after the method is enabled. The setup entails for an unsupervised process if using means as main classification method. But in this case, the support vector machine will exploit the information encapsulated in the training samples to deliver a classification map already labeled according to the user input. This is not a real-time process and the computation time depends on the size of the image. After launching the processing, a progress bar will appear. Once the computation completed, the result will appear listed in Product Explorer. The classification result can be displayed as a regular RGB image with random color scheme. As an alternative, each class can be displayed as a single layer on top of the initial product. Use Layer Manager tool to handle the classes. They are stored as independent masks and the user can decide which one to visualize by checking or unchecking the boxes. For advanced interpretation, use exploratory visual analysis and the factor analysis data representation. Assess individually the classes by overlapping with the source product in different representations. If you are curious to try it, please access the Snap web page.